Okay, hello, everybody. We're just gonna give another minute before we launch this webinar. It's 10:59, so we'll give it another minute and then we'll start right on time. Thank you all for joining. We're just gonna give it a few more minutes or one more minute, and then we'll go ahead and get started. I see people coming in now. All right. Just a few housekeeping items while we're waiting for people to come in. This is a webinar, so all participants except speakers are muted. And if anybody has any questions, we're asking that you please post these in the Q&A. Not in the chat, but in the Q&A, and we'll field those at the end of the presentation. And I think that, yes, this presentation is being recorded, and it'll be available on our website in a few days. Okay, so I'm gonna go ahead and get started. Let's see here. Okay, so good afternoon. It's my pleasure to host this webinar today focused on food waste reduction and pollution prevention. My name is Krista Schneider, and I am your host for today. I am a technical advisor for the Pennsylvania Technical Assistance Program at Penn State, also known as PennTech. And if you're not familiar, we are a statewide grant-funded organization housed within the Office of Entrepreneurship and Commercialization at University Park. And our mission is to support Pennsylvania businesses. We focus mostly on small to medium-sized manufacturers and startups. And we do this to advance economic development throughout the state. And the way we do this is by providing direct technical assistance, as well as by providing access to faculty and students through facilitated engagement. All right. And you can see here that the work that we do is aligned with these UN Sustainable Development Goals. And we work closely with state and federal government agencies, as well as other economic development organizations, both inside and outside the university. All of the work that we do is, like I said, funded by grants, and you could see that some of the the agencies and the organizations that fund our work, and it's through these programs that we're able to offer our services at either mostly no cost or very limited cost. And this presentation, in fact, today is funded by the Environmental Protection Agency, the EPA, through a pollution prevention grant. So how do we measure our impact? Well, we do that by measuring our economic benefit that we bring to our clients. This could be either in the form of energy savings or grants or jobs. And we do this through, like I said, also through our facilitated engagement with access to faculty and students. And I'll come back to that part of our technical assistance at the end of this webinar. But right now, let's talk about why we're all here, and that's food waste prevention. So just real quick, to begin thinking about evaluating the waste prevention strategies, it's first important to understand the difference between mindsets, right? The difference between a circular economy mindset versus a linear one, and a linear view. A linear mindset really kind of views waste as something to be disposed of, whereas a circular mindset looks at waste as instead as a valuable resource to be recycled or reused. And you can see that this document here on the right, this is the guiding document on this approach, and we'll be referencing it here today throughout the presentation. So, there's a lot on this slide. I apologize, but I just wanted to show this because there's a lot of strategies for food waste prevention. You could see the EPA has researched this, and they've researched the environmental impact of each of these different pathways, from a carbon emissions standpoint. And they came up with this food scale, which is on the left. And what this does is it characterizes the most preferred, which is the least energy intensive to the most energy intensive waste pathways. And so in the US, more than 60%, that little orange arrow there, has more than 60% of food waste is that's generated by manufacturers is being handled by those practices on the right. And we want to work to move them more to the left. And you're probably thinking, well, food waste is organic, so what? It's just being recycled, or it's being put back into the soil. And that's true, but there's still embodied energy in that food production and each of these disposal methods. And so EPA's goal is to get more manufacturers to use the practices in the left side. And that's what this presentation is really focused on. The left side of this diagram, specifically prevention and upcycling. And the two guest speakers that we have today will speak about this in more detail. Dr. Ziegler, who I'll introduce here in just a few seconds, he's going to speak about the science and the economic perspectives. And then Matt Silvera from the Hershey Food Company is going to offer a corporate perspective. And so after their presentations, I'll discuss the tools and the resources that are available to advance these strategies. So Dr. Greg Ziegler is a distinguished professor of food science at Penn State. He also serves as the director of graduate studies and director of the Food Characterization Lab. His expertise is in food process engineering and food material science. And his research revolves around foods as composite materials. And he has extensive expertise in the science and engineering of chocolate manufacturing, as well as food waste upcycling and product commercialization. In fact, in 2016, he and a colleague founded a startup company called Persan Naturals, specifically to commercialize their research of the avocado seed as a natural colorant called Avocolor. And he's going to highlight this in his presentation. And so I will turn it over to you, Dr. Ziegler.
All right. Thank you, Krista. And welcome, everybody. Have a good morning. So I organized my comments around this draft national strategy for reducing food loss and waste. This was put out, I think, collaboratively by EPA, USDA, and FDA. And specifically, what I want to emphasize is utilizing those resources for their highest value possible. And that's generally to recover these and make them into edible foods. And there is a distinction between food loss, which happens during processing in this case that we're talking about, and food waste, which is really post-consumer. And I'm going to stick to food loss. So we're looking at, how can we minimize or recover lost food in process operations. Okay. This will be interesting because I don't see the little controllers on the bottom. There we go. Okay. Okay. So the first objective in this framework is to prevent the loss when possible. When that's not possible, an alternative is to upcycle these food ingredients or products, byproducts of processing, into new foods for human consumption. So this is kind of where I'm focusing today, but we'll talk about other alternatives too. One of the first things I want to emphasize is the fact that there's probably a good need to address contamination. Oftentimes, once we designate something as waste, we treat it as if it's going to the landfill and not as if somebody's going to be consuming it. And so it may take a new mindset. We have to start thinking about these byproduct streams as edible materials. So EPA put this document out, and I thought it was interesting to take a look at this. I think if you look at the materials that are pictured here, maybe only some of them would most people consider as food. And in this case, food is the wholesome edible material that people would normally consume. And we typically wouldn't normally consume eggshells, but there is a possibility there for recovering some valuable materials, even from things we may not consider food at the outset. Okay, so Krista mentioned that there are a number of things we can do with these byproduct or waste streams. And what I want to emphasize is this whole idea of value addition. I want to take this material that on the left would typically be discarded, and we want to work towards the right and increase the value of our byproducts. So if you look at this, if we divert it from a landfill, it's organic material, we could compost it, we could send it to anaerobic digestion. There are actually maps online. You can find composting facilities and anaerobic digesters statewide from an EPA website. We move it one step further, we can make non-food and feed materials out of this. This might be materials that end up more in industrial applications. Beyond that, we can add some value by using it as a fermentation feedstock. So here we might use that just to produce energy. In this case, instead of anaerobic digestion where you'd have methane, maybe you're using it to produce ethanol, something like that. Again, another step up in the value chain. We could use it as animal feed. Above that, human food. And then there are times when we can extract some very high value materials that could be used as supplements or pharmaceuticals or cosmetics, that type of thing. So we're increasing value of those byproducts as we move from left to right in this chain. Some of the things that may be important to consider about these byproduct streams are its edibility and specifically its food safety. Again, typically you have to handle much of this material as if it was food to keep it safe. You might want to consider homogeneity. Is it the same material I'm dealing with on a daily basis, or is there a variability in my waste streams? Moisture content may have a lot to do with how long it will stay safe. Typically, things that have high moisture contents will degrade faster. You want to consider the energy content, especially if I was to divert it, for instance, to a fermentation feedstock or something like that. Oil content, oftentimes we may have to separate oily streams from water-based streams. And then finally, depending on the application, it might require certain nutrients, for instance, proteins, if I'm using it in fermentation, and its carbon content. I'll reiterate that we want to make sure we maintain these streams in the absence of contaminants. Now, fully utilize some of these byproduct streams may require some additional processing, perhaps sorting and source separation. Again, dividing things that from non-food items from your food streams, for instance, may require separation, especially magnets for metal separation. Oftentimes requires washing, grinding, mixing these materials. Could require sterilization or pasteurization. And if your waste stream is prepackaged material, it may require depackaging before you can recover any value from it. Here we go. Okay, so I want to go through really quickly just a couple of case studies. The first one is a case study that's really been going on now for about 50 years, and that's the utilization of cheese whey. If I look at 100 pounds of milk, by the time I make that cheese, I end up with about 90 pounds of whey. And that whey is mostly water, okay, 93 to 94%. But we do have 6 to 6.5% of dry matter. A fair amount of that is protein, but the most of it is milk sugar or lactose. So is there a way we can recover some valuable materials from this whey? Otherwise we lose 6.5% of our solids. I always like this graph when I'm talking about upcycling. I don't know how many of the folks in the audience here would know what happened in 1970 that started this whole thing going, but that was the year the Clean Water Act was promulgated. And so what you had was no longer could cheesemakers just dump their whey in the local river. And so they had to start recovering this material. So at first it was just simply dried, and most of it ended up in animal feed. Okay, so the water was removed from it and those solid materials ended up in animal feed. About 10 years later, though, people started to say, you know, the proteins in whey are both nutritious and functional in a food system. So we're going to start isolating those and separating those from the lactose. And so when you start to see that happen, you start to see whey protein concentrate and lactose being generated, and less of that, okay, being used in animal feed. In fact, out to about 2005, really very little whey goes into animal feed anymore. So that's up to about 2005. If we look at what's going on more recently, we not only take those whey protein concentrates, now we take a look at the whey protein, we can see it's got a number of different materials in it. We can start to make these whey protein fractions, and you can see now I'm going $15 to $600 a kilogram versus $10 a kilogram. For instance, the example I give here is lactoferrin. It's only 0.2% of the protein fraction, but its value is high enough that now you can buy isolated lactoferrin. So again, you know, it wasn't until 1970 we got the Clean Water Act, and here's something that now we have these valuable materials that have come from whey. What's going on in the future? Well, if we look at buttermilk or butter serum, this is the aqueous material that's left over after butter making. We actually have still some milk fat globules that end up in the whey. It's called whey cream. And the milk fat globule membrane has some very bioactive materials that actually, in this case, things like the cerebrosides that help with nerve generation. And so now people are recovering this milk fat globule membrane, putting it into things like baby formula. So we're getting, you know, even higher value items. This is possible because you have large facilities making lots of cheese, have extremely large amounts of whey available, and can immediately take that whey into a byproduct stream for processing. So even materials that are minor components in the whey are now being isolated and included in food products. One that's coming up, which is kind of interesting, is that whey also has these things called oligosaccharides in it. These are short chains of sugars. It turns out that our bodies or humans cannot digest these oligosaccharides, not even the ones that are in human milk, which is a bit interesting. But they are digestible by the probiotic bacteria in your gut. And so now what you can see, this is actually a material, this is human milk oligosaccharides, okay, that have been isolated as a prebiotic powder. People are now looking at the bovine milk oligosaccharides. So these, again, a high value item that's now being isolated from whey. Okay, so that's a good example. Now I want to kind of move into a less than ideal example. This is waste from a tomato processing facility making tomato juice. So you can see this is largely a pile of tomato skins, tomato seeds, a little bit of pulp left over. And I think they moved this material around using a front loader, and it's just sitting out here. But there's a lot of it worldwide. And so the question becomes, what can we do with this? One advantage, if we could make use of that waste, it would prevent us from actually having to grow so many tomatoes. And this is one of the ways that energy and time and money is saved through waste utilization. And that's by avoiding the food production the excess food production you have to do to generate that waste. So this upcycling pathway that I'm talking about, again, captures the environmental benefit of avoiding that additional food production. Now, there was a company, LycoRed, that looked at that waste tomato product, saw that it was very red, and said, there's a lot of lycopene that could be produced from that tomato waste. And so they actually started doing that. One of the challenges they have, though, is in an adequate and stable and safe supply chain. They ran into problems with that. So now this company actually grows their own tomatoes to now extract lycopene out of them. So they were really not able to utilize that waste material. So now what's going to happen with this waste material? Well, I did find this little startup here now. That's kind of interesting. They're taking these tomato byproducts, mostly the skins. They're extracting materials out that will actually make a lacquer to lacquer the inside of food cans. Obviously, tomatoes, packaged oftentimes in food cans. So they're looking at this idea of a circular economy here. Now, the lacquer does not use everything in the waste. And so what's left over that they can't use for lacquer production goes into biogas. Okay, so this is an example of material going into a non-food stream. Again, there are still issues with supply chain. I know a lot of the companies that maybe would want to buy this lacquer want to be sure there's enough on a continuous basis so that they don't run out. And so matching a waste supply stream to the final product is really, really important. Ideally, what one would do is set up a process with the actual intention, pre-think this out, the intention to recover materials, instead of just waiting till it ends up in a waste pile and then trying to recover it from the waste. This is an example of tomato seeds. And this is a process for making tomato juice down here, but it recovers the seeds in a clean manner. I've actually worked on these a little bit. They have about 36% protein, and maybe you can imagine how many tomato seeds there are in the world, but there's quite a few if you think about all the tomato paste and tomato juice and everything else that we manufacture. The challenge I had is that by recovering these from a waste product, there was already some degradation. And when we recovered the protein, it had a bit of a barny kind of smell to it. So again, the ideal way to think about this is to look at your process and see if there's a way I can intentionally integrate the recovery of these valuable materials in the process itself. So while I'm thinking about seeds, as Krista said, I started a small company to make use of avocado seeds. You can see avocado production, obviously, in the last 20 or 30 years has really gone up. Importantly, that production and that consumption of those avocados is often in pre-processed products. So it's not like I had to run around and think about collecting seeds from people's trash cans. These companies that process the avocado flesh have a lot of seeds left over. In fact, the seed is about 16% of the fruit weight. And in these processing facilities, you start to see piles of seeds just accumulate and accumulate. This is actually a small pile, a very small facility. Some of these are just mountainous at some of the larger guacamole manufacturers. So we wanted to generate some value out of these seeds. And what we ended up doing was producing this natural food color. It's a yellow to red kind of colorant, called it Avocolor. One of the not the downsides, but one of our concerns about this is that this color only represented about 2% of the seed weight. And so we still had a lot of material to get rid of. And here it's important for us to know, what's the composition of that remaining material. And in this case, it's starch, it's fiber, the kind of things you'd expect out of a vegetable material. And so what we did is we worked with a kind of a partner company. They took that fibrous material. They were able to work about 20 to 25% of it into paper manufacture. Okay, so they made very nice paper out of this fibrous material. You will see, though, it has still a little bit of a pink color. And again, that comes from the avocado itself. We can't extract all the color out of it. But that's a use for the remaining material that after we extract our color. So, what we did is we did some thinking. We took our avocado seed and we understood the composition of this. So it's very important to understand what materials are in there. We started to look for applications of each of these materials, including some of the very minor components. For instance, these fatty alcohols, they're very interesting. They have anti-cancer properties. So you'll see online sometimes people tell you to make a slushy out of these seeds for anti-cancer. I'm not pushing that here because I'm not that kind of a doctor. But the idea is, how can we utilize the whole material? We want to get it to the point where there's really no waste or very, very little. Okay. See if I can find my buttons. So I want to end with a few comments. Oops, I don't know why it's jumping here. A few comments about why waste occurs. And one of the things we have to be aware of are the psychological acceptance of some of these products from the standpoint of a consumer. I think it's hard to tell somebody, although it might sound exciting, we took this waste product and we made your food out of it. So I think it's important the words we use, maybe we want to talk about byproducts or other products or co-products, things like that, because there is a psychological resistance to this kind of material. For example, the meat industry uses something called advanced meat recovery to take meat off of bones. And despite the fact that it has a very good nutritional profile, as good as regular meat, people reacted to this by calling it pink slime. And so this idea that I was going to take a byproduct from meat processing and put it into hamburgers or something, and it got a consumer reaction that wasn't all that good. I think the way we put this in context, for instance, okay, this is advanced meat recovery. I always tell people, well, what's not so advanced meat recovery? That's what I do in my kitchen, and your grandmother probably did. And that's when you take that same meat on the bone and you cook it up and make stock out of it or soup out of it, that kind of thing. So I think positioning your products appropriately to your consumers is important. That brings me to my last little example. When I first started working here, I got contacted by a company that made roast beef for the deli trade. And these roast beef would be cooked in a bag. Now this one, not in this bag, they would actually cook it in a bag first. And that bag would accumulate a lot of juice that came out of the roast beef. Like au jus, if you make roast beef with au jus. They would cut that bag open and discard that juice and then repackage it into this final bag. And they asked me if there was anything that they could do with that juice. And we actually came up with some good ideas, took those back to the company, and they ultimately decided not to pursue that. And this is what they told me and why they decided not to pursue it. They also made corned beef and pastrami, and people want these nice even slices of corned beef and pastrami. And so when they got to the end of the slicer, there would be a little piece that didn't look very good. And so they decided to convert that into corned beef hash and sell corned beef hash. Well, the corned beef hash got so popular, they found out that they were grinding up whole briskets and everything to make corned beef hash, but they didn't make as much money from the corned beef hash as they did from the brisket itself. And so they discontinued that. I have some folks in business that said, well, what they didn't do was put a differential price on these such that they balanced those supply chains out and got the most out of the entire brisket. So I'm going to wrap up now with a couple of takeaways. I think the first thing you need to consider is waste reduction. That's going to save the most energy. It's going to save the most environmental impact. But we know that any process, especially food processes, are going to produce some kind of waste stream or byproduct stream. So we need to conduct a detailed material and energy balance on our whole process. And we need to include in that a detailed composition of all the streams that we're going to be handling, because that's where we're going to derive our value. The most value, both economically and environmentally, comes from upcycling. If we can keep this in the food stream or even up to the pharmaceutical stream, it would be great. To do this, though, it requires that this, quote, waste has some food value, and that throughout the process, we treat this waste as food. And so, again, even within your company and everything, you may want to change the terms that you use for this material so that people respect it as food. In all of this, we need to consider regulatory issues and the consumer perception of where this material came from. And some of that is going to depend on whether you're making a product for another company, so like an ingredient, that your business is B2B, or that you're actually going to a retail product with a consumer. So Krista, that's my pitch today.
Yeah, thank you. That was awesome. Thank you, Dr. Ziegler. It's a lot of great information, and we loved seeing your examples there with all your experience. Let's transition to Matt. I want to introduce Matt, and then after his presentation, I'll finish with a few slides, and then we'll open it up to questions. And like I said, if you have any questions throughout this presentation, please post them in the Q&A, and we'll look at those at the end. But let me introduce you to Matt. Matt Silvera is the Manager of Environmental Sustainability at the Hershey Company. It's coming up on Easter, so everybody should have Hershey chocolates on their mind. Hershey, as you know, it's a Pennsylvania-based manufacturer of chocolates and other snacks. It was established all the way back in 1894, Hershey, Pennsylvania, and it's since grown to be a global company. And let's see, since joining Hershey in 2021, Matt has helped build the company's integrated environmental sustainability program. And this touches on everything from decarbonization and sustainable farming practices to bio-based packaging and, of course, food waste recycling in their manufacturing processes. And he's going to speak briefly about that today to offer a corporate perspective. So I will turn it over to you, Matt.
Yeah, thank you, Krista. And first of all, I just want to say thank you, Dr. Ziegler, for the takeaways. I really liked your focus on being intentional about recovering as much value out of waste as possible. We certainly see a lot of value in waste and have seen how it touches many of our operational priorities. So on the top, you'll see our operating priorities, which are COCO, responsible sourcing and human rights, environment, and our people. And the way that this touches those is, like you mentioned, if you are able to utilize more of your ingredients, then you're sourcing less product. You're able to use some of that product or those waste streams in your value chain to help support your value chain, and certainly reducing environmental impact and engaging your employees through different waste strategies. And this is all grounded in our foundational priorities of youth and community. A lot of our programs do engage the community and help the communities where we live and work. We'll go to the next slide. So we do have food waste in our manufacturing process, but very little actually goes to landfill, almost none. The vast majority of food waste is beneficially used in some way. In 2022, we had a 78% company-wide waste recycling rate, and some of the areas where we are still continuing to try to find solutions for are in that inorganic material. But for our organic material, we have lots of beneficial use. We are prioritizing waste reduction at Hershey because it does help us in so many ways. It helps reduce demand on landfills and limit pollution from disposals. It saves costs and saves resources, and it helps with engaging our employees. On the right, you'll see we follow similar practices that Krista shared earlier on with the waste hierarchy, in terms of first starting with preventing and finding ways to not generate the waste to start with, and reusing that product as much as possible in the process. We also engage with a lot of agricultural partners, and we try to listen and identify opportunities. And I'll be sharing with you guys a case study here shortly. And then recycling, working closely with employees. A lot of our initiatives have been employee driven, as employees have some great ideas on ways we could better manage and reduce our waste. And we continue to make progress on circularity. So circularity is a very important topic for us, trying to create that circular economy. And some of the ways that we're doing that is some of the highlights. One is through zero waste at some of our manufacturing facilities. So we have 3 in 2023 with 100% recycling rate. We even look for opportunities in the office dining facilities and other options. One example that I wanted to highlight, as I was preparing for this webinar, I was asking, how did this partnership on diverting food waste from landfills with Cargill begin? And and they mentioned him as Penn State University. So want to really encourage everyone to identify partners. So partners help you do projects better, faster, provide the much needed expertise and assistance, and help identify a lot of great solutions. As Dr. Ziegler presented so many different ideas that we would, or most would never have thought about, but when you have the right people and the right expertise, it opens up a lot of opportunities. So we're working to divert food waste from landfills, and one of the ways is an input to livestock feed as a nutritious supplement to their feed, especially to add caloric value during the winter months. And it helps with circularity in that it's the same farms that receive a lot of this feed provide the dairy milk for our products. So creating that circular economy. And it's one of many initiatives that we're doing with our dairy farms, or not our dairy farms, but the dairy farms that supply Hershey. We have a number of projects through our Sustainable Dairy PA initiative, with manure management, creating riparian buffers, and a whole host of things, but this is one of them, through that circular economy. And it does help a win on many areas. So win on costs, win on saving millions of pounds of chocolate from landfill, repurposing some of that packaging. So as Dr. Ziegler mentioned before, that pre-treatments to be able to extract as much value as much as possible. So even in this, we're extracting first, what product can be reused as to make chocolate, and then the ones that can't go through this process of being used as food waste back into our supply chain. So yeah, just want to really encourage you guys to think about some partnerships and ways that you can continue to innovate and find waste solutions. So turn it back to you, Krista.
Okay, thank you. Thanks, Matt. That was wonderful. I always love learning more about the work that you do there, and encourage everybody to check out their sustainability programs on the Hershey website, which has a lot of great in-depth information and even more examples. So happy to to be able to share that. So let's just I'll wrap up here with a few more slides about how to if you're a manufacturer or you're working with manufacturers, how do you begin basically to start thinking about examining and evaluating greener alternatives for managing food waste, especially for the small and medium-sized companies, that may be limited in terms of their resources or their expertise. How do you get started? Well, I guess, the one takeaway I would like you to have today is that, you could start right here with Pentap through our services, our energy services. We do, like I said, direct technical assistance. We do energy assessments and energy efficiency assessments and pollution prevention assessments. And how does this work? Well, the first thing that we could help with is a baseline assessment, and that's understanding, what is your current energy consumption, how much, and what kinds of waste, say, are you producing? We can help identify some of the low-hanging fruit in terms of efficiency and improvements that could be made. And then this could lead to, maybe identifying opportunities for more detailed assessments of waste streams, and then, evaluating the energy associated with those different disposal methods. So for instance, this could involve something simple like a food waste audit, which is, being very intentional about evaluating, what is being thrown out and why, weighing it, quantifying it, understanding, how it got there, and why it is a waste product. This could also involve, I guess after you have your baseline, I guess that's what you need basically to identify your company goals. And this could be as simple as setting targets for those energy savings and waste reductions, knowing what your baseline is, knowing where you want to get to. And we offer special training programs for that. We have what's called energy management systems training. We also have a special grant funded through the Department of Energy, what's called the 5001 Ready training program for those that really want to, create a corporate, say, decarbonization plan. And then if your company really wants to look holistically, like Hershey, say, and you want to establish what's called an ESG plan, and ESG standing for environmental, social, and governance goals. Looking to evaluate your organization's, not just environmental, but your social impacts, we can help with that too. My colleague Heidi, in fact, just hosted a webinar on this very topic a few weeks ago. It's available on our website, and like I said, we could point you in that direction as well. A free tool that's available that we could also assist with is this EPA calculator called WARM, Waste Reduction Modeling Calculator. It's a very high level, back of the napkin way to just get a general idea as what your potential, greenhouse gas or energy savings can be using different disposal and recycling pathways. So it's all based on tons of food waste avoided, recycled, whether it's landfilled, combusted, composted, whatever. So it's basically trying to look at, different sources of waste and how they're being disposed of, and making evaluations based on that. And it also even gets into estimating savings for labor as well. And so one of the other things we didn't talk about very much, but composting or say donation. If you want to say you evaluated some of these higher level recovery options, but then there's waste that you just can't say recycle or reuse. This is a great tool. EPA's Excess Food Opportunity Map, Dr. Ziegler mentioned it in his presentation. It's not only a list of prominent food banks throughout the country. Here I'm showing, those listed in Pennsylvania, but also compost facilities, as well as digesters. And so, as Dr. Ziegler mentioned before, in order to know if a food product can be donated, it's important to understand the food safety laws, and we can put you in touch with those technical experts as well. Like Dr. Ziegler mentioned, you may have to have special separation protocols. You might have to rely on warehouses or refrigerated storage, for temperature control and such. And so there's a lot of, and those are on this map as well. And so, as you can see, there's a lot of options and a lot of factors to consider. And, if it seems overwhelming, how are you going to begin? Well, maybe we can help with that too. And, through our innovation services. And so if you're looking at, say, evaluating a particular process, Penn State students, can take that on as a class project, whether it be through the College of Agriculture, the College of Engineering. There's even some programs like biological and agricultural engineering students that are looking to help with life cycle assessments, and these holistically evaluate your product supply chain. So there's all sorts of different resources. We also partner with our local industrial resource centers throughout the state, and they have continuous improvement consultants. They could spend a few days working with your company to identify process improvements, and we can help with the, evaluating the associated energy savings with those improvements. And then if you're looking, say, to monetize a waste stream, like those examples that Dr. Ziegler showed, Penn State has resources for that too, in terms of, research partnerships or even access, to no cost programs, say through Invent Penn State, to look at maybe even startup company initiatives. And, through our technical assistance, we could also help identify grants that are available to help pursue these improvements. And one special program that I just wanted to highlight here before we conclude is this a short course that we are hosting in partnership with, or we're hosting in partnership with the College of Engineering. And it's designed for manufacturers, small and medium-sized manufacturers, to explore ideas, especially for, problems in like a problem that you have, and you want to innovate out of the problem. And so it takes a human-centered approach that balances feasibility and desirability. So some of those things that Dr. Ziegler mentioned, with like the social side of perceptions and desirability of a food product. And so this isn't geared specifically for food, but it is certainly very applicable to the discussion that we're having today. It meets weekly for 4 weeks. It's free, it's online. And when it's complete, you receive a micro-credential for it called Leading Through Innovation. And that is available You could find that through our website as well. And then, just to say here, again, as our main takeaway, we'd like you to consider Penn Tap as your one-stop shop for all of these technical assistance and engagement opportunities at Penn State. We have our advisors are dispersed throughout the state. You can see each of us here represent different regions. And you could see I'm there highlighted. You could contact me, or you could contact any of these advisors. I represent Northeast Pennsylvania. We're embedded in the regions that we serve in order to, make connections with local partners. And we are happy to do that. And so that is the last slide I have. And I think I'd like to conclude now and just say thank you to everybody for participating in joining us today, and also especially to Dr. Ziegler and to Matt. Thank you so much for your presentations. They were wonderful. And I'll just open it up now to any questions. I don't think I see any that I can find in the chat in the question and answer. Let me see if there's one here in the chat. Oh, yes, there's a question here. Are there any state level legislative or policy approaches that could encourage productive use of food loss and waste? I do believe there are. I think I saw some grants that are out for that. There are certainly pollution prevention and energy efficiency grants that are available through the USDA. In fact, Penn Tap is we've been working with several clients and farms even, especially throughout the state, small businesses that are located in rural areas and small businesses elsewhere, to help identify energy efficiency improvements and pollution prevention improvements. And so one of the first things that you need, like I mentioned in the presentation, is a baseline assessment, and we can help with that. So that's from the grant funding side. I don't know if, let me see if there's any other questions. Yes, I have a second question here. And Dr. Ziegler and Matt, please jump in if you think that there is anything here. Is there the question here from Greg, is processing brewer's grain for animal feed on the radar? Maybe Dr. Ziegler, that's a question for you.
I can say yes. I've actually seen a number of attempts to use some brewer's grain for human food, and so yeah, I think there are significant efforts going on in that area, but certainly for animal food.
Yes, I do know a lot of brewers do already either donate or upcycle, for profit brewer's grain, spent brewery grain for animal feed. We have some personal experience with that. So I'm happy to, if there's any questions, specifically, for brewers that want to get in touch with us, I'm happy to field those questions as well. Another question, any thoughts on upcycling food waste through feeding to insects? The insects would then be product for animal feed or other routes.
Yes, there's work going on that, especially for producing things like army worms and stuff for chicken feed. One thing you have to be aware of, though, is, people think that insects will eat anything, which is not true. You need to find the right insects to eat the right foods. Some insects are very narrow in their food choice. So that's one where you really have to know what you're dealing with, what your product is, and what insect that might be valuable for instance, for chicken food, whether they would eat it or not.
Interesting. Well, I don't see another question posted just yet, and so I will take the opportunity, Matt, to ask you. I know we talked a little bit about this briefly offline the other day, but could you mention or maybe talk a little bit about what your company does with the cocoa beans as an upcycled product?
Yeah, so we do purchase cocoa products, so cocoa butter, cocoa liquor, cocoa powder, and any product that isn't used in the candy bar and that is reusable, we do rework that back in the process to be reworked. And then what is then not usable, it goes to the other processes I mentioned before. We are exploring through cocoa R&D some farm resiliency practices, like using corn husks for soil amendments, like biochar. That's still in the early phases to be able to replace like fertilizers and things. But we are exploring those types of options on farm as well.
Great, very, very interesting. Okay, well, let me see. I think that was the last question. And if there's any final words from any of our speakers, feel free to say whatever as a wrap up. But I would just like to thank everybody and encourage you all to reach out to me or to any of our advisors. You can reach out to Dr. Ziegler, of course, directly. I had Matt's contact information on one of the slides. And so this presentation, as I mentioned, it is being recorded and it will be put up on our website. You can see it down there on the right, pentap.psu.edu in just a few days. And if there's any last words, we could take them, or we could just say thank you to everybody. So I guess we'll wrap up and have a great Wednesday afternoon, and thank you all for attending.
Thank you, everyone.
Thank you.